Another kind of problem that is associated with trigonometry is one similar to something like either of these, where we want to solve the triangle. But we bring this up not because you can't use trig functions to solve it. You can, but because it's actually easier than that, and it's good to know that you can solve the problem a little bit faster. Suppose we have a triangle like this, a right triangle, first of all, and one of its acute angles is 45. The hypotenuse is 6. What are the lengths of the legs, x and y? Well, this one is pretty straightforward. If this is a 45-degree angle, then so is this one. Now, we know from our special triangles that we memorize for the special angles is if you have a 45-degree angle and 1 for the hypotenuse, then each leg has the same length of 1 over root 2. So I can compute this. I know that this triangle is similar to this triangle, and I can compute this x and this y, for that matter, by using the technique of similar triangles. This leg is to the hypotenuse, as this leg is to its hypotenuse. Now that's 1 over root 2 divided by 1, which of course is just 1 over root 2. Then you multiply each side of the equation by 6. X is 6 over root 2. Some people prefer to multiply top and bottom by root 2, so they say 6 root 2 over 2 or 3 root 2. So there's the length of the side labeled x here. And we know that since this is an isosceles triangle, that the angles are the same, then the legs have the same length. So there you have it. We've got that one done. All right, suppose we have one like this. We have a right triangle, and one of its acute angles is 30 degrees. The length of the side opposite that is 5. Find the length of the other leg, and for that matter, you might also ask for the length of the hypotenuse. Okay, well, we know that since that is a 30, 60, 90 right triangle, it has to be similar to this one. If the hypotenuse is 1, 30-degree angle is opposite the leg of length 1/2, and the 60-degree angle is opposite the leg of length root 3 over 2. So that's my old stuff over there. Okay, we can just now compare the two triangles. This, let's see, this longer leg is to the shorter, as this longer leg is to the shorter. Now multiplying up and down by 2, that just gives us root 3. So if I multiply both sides of this equation by 5, I get 5 root 3. Now we recommend doing it this way because it's easier, it's faster than going through the trig functions. Nevertheless, you could go through the trig functions. So how about if we do that on this one right here? What we know is that we have a triangle, a right triangle. We have an unknown leg here. We have a leg of length 5 here, and we have an angle of 60 degrees here. So the tangent of 60 degrees is equal to the opposite over the adjacent, y over 5, and we could also figure out the tangent of 60 degrees. Well, that comes from a 30, 60, 90 right triangle. Which is this. The tangent of 60, opposite over adjacent, be root 3 over 2 divided by 1 over 2, so it's just root 3. the y-coordinate then, we have root 3 is equal to tan 60, which is also equal to y over 5. So if you multiply through by the 5, you get y equals 5 root 3. And sure enough, that gives us the same result as up above. But it's just it's an additional complication to bring in the tangent function when you could simply do this by the method of similar triangles. Now, where does this sort of thing ever come up? Well, let's suppose we take a word problem and give an example. We have two cars that are going to be going on routes perpendicular to each other. Let's say one car is traveling north, the other car is traveling west, and we are going to assume they're both running at the same speed. So these distances between the two that the two cars have traveled will always be the same, and therefore this angle that's being formed here will be a 45-degree angle. Maybe we're testing out some electronic equipment or something communicating between the two cars, and we would like to know when will the two cars be, let's say, 5 miles apart. How far do they both have to drive before the direct linear distance between the cars is 5 miles? Well, you'd solve the problem just the way that we solved this one right up here. We'd say that this is similar to our special triangle. So if we want to know this distance here, x for instance, we'd say x is to 5 as 1 over root 2 is to 1. Divide that by 1, you get this. And so x equals 5 over root 2, or maybe in a little neater way, 5 root 2 over 2. So that's a case where we could solve this. You could run it through a trig function if you wanted to. You get the same result, but it's faster and easier to use similar triangles.